Greetings, welcome to this new video about Supermesh analysis. Solve the problem number 9. Let's consider this network consisting of 4 resistors labeled R1 through R4 as well as 2 voltage sources V1 and V2 and 2 current sources IA and IB. The question now is to calculate the mesh currents. Let's move on to the solution. First, let's begin by defining the number of meshes in this network. It's evident that there are 4 meshes. This is mesh number 1, mesh number 2, mesh number 3, and mesh number 4. Now let's proceed to assign the mesh currents in this network, and I will consider I1 is the current in mesh 1, I2 is the current in mesh 2, I3 is the current in mesh 3, and I4 is the current in mesh 4. The mesh currents are chosen in the clockwise direction. After we finish the assignment of the mesh currents, we need to remove the branch containing the current source IB. Then we obtain our supermesh. Let's start first by applying KVL in supermesh. We can write R1 I2 minus I1 plus V1 plus R4 I4 plus R3 I4 minus I3 is equal to 0. By replacing the resistors and the voltage with their numerical values, we obtain 6I2 minus I1 plus 10 plus 2I4 plus 4I4 minus I3 is equal to 0. If we continue simplifying this equation, we obtain negative 6I1 plus 6I2 plus 6I4 minus 4I3 plus 10 is equal to 0. And I will call this equation 1. We can observe in mesh 1 that the current I1 is equal to the current IA is equal to 4 amps, and I will call this equation 2. Let's move on to mesh number 2. By applying KVL in mesh 2, we can write R2 I3 minus I1 plus R3 I3 minus I4 minus V2 is equal to 0. By replacing the resistors and the voltage with their numerical values, we obtain 12I3 minus I1 minus 8 plus 4I3 minus I4 is equal to 0. If we continue simplifying this equation, we obtain 16I3 minus 12I1 minus 4I4 minus 8 is equal to 0, and I will call this equation 3. We currently have 3 equations with 4 unknowns, which means we require 1 additional equation to solve this problem. In order to get this equation, let's focus on the current source IB. We can write IB is equal to I2 minus I4. That means I2 minus I4 minus 1 is equal to 0, and I will call this equation 4. After we finish applying the supermesh analysis, we obtain 4 equations with 4 unknowns. We still only need to solve those equations in order to find the mesh currents. Let's start first by substituting equation 2 in equation 1. We obtain negative 24 plus 6I2 plus 6I4 minus 4I3 plus 10 is equal to 0. If we continue simplifying this equation, we obtain 6I2 plus 6I4 minus 4I3 minus 14 is equal to 0, and I will call this equation A. Now, by substituting equation 2 in 3, we obtain 16I3 minus 48 minus 4I4 minus 8 is equal to 0. If we continue simplifying this equation, we obtain 16I3 minus 56 minus 4I4 is equal to 0. That means we can write I4 in terms of I3. I4 is equal to 4I3 minus 14, and I will call this equation B. From equation 4 we can write I2 is equal to I4 plus 1, and I will call this equation C. By substituting now equation B in C, we obtain I2 in terms of I3. I2 is equal to 4I3 minus 13, and I will call this equation D. By substituting equation D and B in A, we obtain, or we derive, one equation in terms of I3. If we continue simplifying this equation, we obtain 44I3 minus 176 is equal to 0. That means I3 is equal to 176 over 44 is equal to 4 amps. Now from B we have I4 is equal to 4I3 minus 14. That means I4 is equal to 4 multiplying by 4 minus 14. We obtain I4 is equal to 2 amps. And from equation D we have I2 is equal to 4I3 minus 13. That means I2 is equal to 4 multiplying by 4 minus 13. We obtain finally I2 is equal to 3 amps. After completing the calculation, we conduct the simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. We can see here this is the current source IA 4 amps, IB 1 amps, and the two voltage sources V1 10 volt, V2 8 volt, and our 4 resistor R1 through R4. Let's go to analysis, DC analysis, calculate nodal voltages. We can see here that the current I2 is equal to 3 amps, the current I4 is equal to 2 amps, and the current I3 is equal to 4 amps. Those values are exactly the same value we have done by calculation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. Take care and bye bye.